So my name's Robin, I work for a company called Confluent. Show of hands, who's using Apache Kafka today? Good stuff, about half of you. Who's heard of Confluent already? Good stuff, this thing works. So if you want to know more about us, come by our stand, it's kind of somewhere over there. I got a bit lost finding my way here today, but we're over that way. And you can talk to us more about Kafka, about streaming, about Confluent platform, and we've got stickers and swag and stuff. But today I want to spend half an hour talking about how you can do stream processing with Kafka. Because people understand Kafka as being different things. Kafka is super popular, everyone likes Kafka, everyone thinks about using Kafka maybe. But some people misunderstand Kafka as just being about like an ingestion pipe. And it's just about kind of, I've got this thing here, I'm going to get some events in, and then I'm going to kind of do something over there. I'm going to go and do some Spark stuff over there, or some Flink stuff, or put them in HDFS and do some batch processing. But Kafka itself is an event streaming platform. Kafka persists data. When you consume data from Kafka, it stays in Kafka. Okay, it's persisted for as long as you would like. You define how long do I want to keep that data, or how much of the data, or by volume. But when you consume data, it's not deleted. So Kafka is this persistent store that you can use for data. And it also provides stream processing capabilities. It provides data integration capabilities. So I want to talk about how we can do stream processing using Kafka. And we talk about stream processing, we're talking about processing a stream of events. And events are actually everywhere. Events are like the obvious ones that we get from sensors and stuff like that. But most of what happens in our businesses is also a stream of events. A lot of the time we decide to model it as like state, we stick it in a database, but that's implementation detail. It started life as an event. So a customer interacts with our business. They phone up, they buy something, that's an event. Something happened, it's behavior that we can capture and model and analyze. And then you have technical events as well. You have readings from sensors, you have readings from mobile devices, you have lots of technical data coming in like that in kind of like the streams of IoT data that we kind of like quite familiar with the idea of. You have events that come from applications. All of those debug statements that we write in our applications and go out to a log file, that's also a stream of events. Every time something happens in your application, it's an event, and we can capture those events. Events also come from databases. I said beforehand, we like to use databases to capture state, but if we've got a database already, we've also got a source of events. So when you start thinking about architecture and how you can use data with Kafka and do stream processing on events, you think, well, I've got my obvious sources of events, I've got like kind of like my clicks on my website, my readings from IoT devices, but for sources of events, you've also got application logs and you've got databases. Databases are a source of events. Databases are built on events. When you do something in a database, when you do an insert, an update, a delete, it gets captured in the database's transaction log. That's kind of broadly how relational databases work. They have a transaction log that captures every single event and then flushes it to a data file, and we work with databases through this like this SQL interface. But underneath, it's a sequential, immutable event log, which, funnily enough, is what Kafka is also. Kafka is this immutable event log mirroring actually how databases work. So a database is also a source of events. You can use change data capture to say, here's my existing database. It's a point of sale, it's inventory, it's whatever it is. I can use that today and get events out of there for whatever my current applications are doing, and I can stream those into Kafka. So Kafka is this distributed, immutable commit log. It's distributed, it's highly scalable, it's highly resilient, but it also has built within it a lot of functionality, which is why we call it a platform and not just kind of like a pub sub thing, or just like this little messaging bus. So you have the producer and consumer APIs. You can use with your various different applications. You've got Java, C, C++, Python, and so on and so on and so on. So from your native applications, send data to Kafka, consume data from Kafka. It also has an integration API, Kafka Connect. If you've got data in Kafka that you're pushing down to a target, you're pushing to HDFS, you're pushing to Elastic, you've got data sat in a database, data sat in a flat file, in a message queue, wherever, that you want to get into Kafka, That's what Kafka Connect is for. It lets you stream data in from different sources into Kafka and push data from Kafka out to targets, and it's just configuration file based. You could write a program. It's lots of fun writing programs. You could work out how do I make it scalable, how do I make it handle offsets, how do I manage restarts and scalability and so on and so on and so on. But once you've done all of that, you've reinvented Kafka Connect. That's what Kafka Connect does. So it lets you get on with building your applications and pipelines. It does the integration piece for you. And Kafka has built-in stream processing capabilities. So when we talk about stream processing, we're talking about taking a stream of events. Something happened. A customer bought something, someone clicked on something, my application did something, something happened. And we want to process that stream of events. We want to be able to say, we've got a stream of widgets. Okay, these widgets are coming in, and some are red and some are yellow, and we want to do something with them. We want to filter it. We want to say, if a red widget arrives, then I want to put this onto a separate topic, because I have a red widget microservice which is going to process those red widgets. It needs a topic to subscribe to. So we can write some stream processing to do this. Take all of the existing data, because Kafka persists data, remember, and every single new event that arrives, we can process it and write it out to a new topic. So we can do it with Kafka Streams. If Java's your thing, you can use the Kafka Streams library. It's part of Apache Kafka, and you can build your Java applications as you would do, but with stream processing built into it. If Java's not your thing, you can use SQL. If you're from a SQL background, like myself, you can write SQL statements which define your stream processing applications. So that is your stream processing application. There is no boilerplate code to kind of like stick around it and work out what the hell's this stuff. It's SQL. If you can write SQL, you can write stream processing applications. So this is KSQL, it's part of Confluent platform, and it's what I want to show you for the rest of today. So you've got data that comes into Kafka. Okay, we've got our source stream. Maybe it comes from an application, maybe it comes from a database, it comes from wherever. It's a stream of data coming into Kafka. It sits in a Kafka topic. KSQL consumes that stream of data, it does something to it, and it writes it back to a Kafka topic. Okay? Consume the data, process it, write it back to a new Kafka topic. From that Kafka topic, it could consume it again. We can daisy chain our processing. So we can say, well, to start with, we're going to apply a schema and cleanse the data, write it back to here. We've got a second application, which will take that cleansed data, and it's now going to build some aggregates on it. Or it's going to join out to another data source and do some further processing and enrichment on it. But the data that goes back into Kafka is just a Kafka topic. So as well as consuming it in KSQL, you can also say, well, actually, we'll stream it from Kafka down to our analytics platform. We'll stream it down to HDFS, up to S3, to Snowflake, wherever we want to put it. Or you can also say, well, I've got the data in a Kafka topic, it's persisted, we can process it further with KSQL, we can stream it down for analytics, we can also subscribe to that topic with our microservice, and now do further processing on it. So you can use it for one or all of these things. Because the data's persisted, you can reuse it and reconsume it. So that's the background, that's the theory. Let's actually do it. All of the code is on GitHub. So what I'm going to show you is kind of like a demo that I've built out. Hopefully it works. Sometimes these things don't. The Wi-Fi is a little bit dodgy, but you can go away, you can try it, you can clone the GitHub repository and try it for yourself. But let's actually see if it's going to work. So let me share my screen. I'm afraid the screen here is kind of small. So that's about as big as I can make the text. My apologies if you can't read it. You can squint or come and squat down here at the front. If I make it any bigger, then we get like one word per row, so that's not going to work. So this here is KSQL, or it's the KSQL client. KSQL, it's a JVM process. You deploy it on a server. I'll talk briefly about that later. Here's one of the clients. It's a command line client. You've also got a web client. You've also got a REST API. So however you want to work with it, you can do so. And to start with, I'm just going to say, what topics have I got on my Kafka cluster? So if you're using Kafka today, you could use KSQL simply because it's easier to work with the data that you got there. We've got a bunch of different topics. We've got one here called data MQTT. Funnily enough, it's some MQTT data. And we can have a look at that, and we can say, well, print out the contents of this topic. So let me show you that. So at the back of the row, you can hopefully see that. If you use Kafka today, you know that you've got a topic in Kafka. I want to have a look what's in it. I need to know how to deserialize it. I use the Kafka Console consumer, I realize it's an Avro, I got some funny characters, I use the Kafka Avro Console consumer, it gets confusing. With KSQL, I can just say, print the topic, show me the contents of the topic. And KSQL says, okay, here's the contents of the topic. It looks like we've got some JSON, we've got the timestamp, we've got the row key, and then we've got the actual payload itself. But the cool thing is that KSQL has said, well, I'll have a look at that data for you, and I've worked out it's in JSON. So I'll deserialize it as JSON. If you're using Avro, which I hope you are, by the way, it will say, okay, it's Avro, I'll go and get the schema, and I'll deserialize it, and I'll show it you. It's just some JSON data. It's JSON data that hopefully we can see working in real time. So let me do this, and this, and this. And we can do that. So, what I've got here, this is just, it's called Own Tracks. It's something you can put on your phone and it lets you track all your stuff. So, it seems kind of scary, but all the other apps you've got, they're just doing it anyway, they just don't tell you. This one at least tells you. So I can say, well, share my location. And in the background, it kind of like shares it periodically, but we can force it to send a message. It sends it up to an MQTT server. Kafka Connect streams from that MQTT server into a Kafka topic. We can see in the background, that topic updates. Every message that I push to it, we get on the Kafka topic. Okay? Oops. So we've got a live stream of events on a Kafka topic from this. And it's stuff like, where am I? There's my longitude, there's my latitude. What's the battery status? Is it draining? How fast am I going? That kind of stuff that you get off your phone. But that's just JSON. And we want to do something with it. We want to be able to say, well, where's Robin been today? And what's the battery status on his phone? How fast does it drain? Are these iPhone 11s actually as good as they say they are? It turns out they are. The battery life is really good. And you can see it going down a little bit. Is it plugged in? Is it on Wi-Fi? Is it on mobile? And you get this kind of stuff out of it, and you can kind of see it. If you start poking through these fields here, you can see, well, there's some things there, and TU, does that mean it was triggered, or is that the battery status? I don't know. And most people at this point may make the mistake of saying, here's some JSON data on a Kafka topic, I'll put it over there, and I'll do some batch processing. I'll write myself a Spark job, and it can pick that up, it can read JSON, and I can do stuff with it. And you absolutely can. But wouldn't it be neater if we could just do this? Let's model the data, let's declare a schema over it within Kafka itself, within KSQL. So I've said create a stream, okay? Create a stream MQTT raw. Here's the schema, okay? There's the schema for my data. It comes from this Kafka topic, and it's in JSON. We know it's in JSON because KSQL told us that already. So I've created a stream. A KSQL stream is just a Kafka topic with a schema. I can say describe that stream. And it says, there's your schema. It's starting to feel a little bit databasey. Okay, we've got an object, it's got columns, they've got data types, and we can actually select from it. So here's my excellent illustration of what we're doing so far. Here's my phone, MQTT data, into Kafka, and we're going to process it with KSQL. And we can do this. So I'll show you it running. So we're going to say, take the timestamp, it's in epoch, so format it into something nice. Select a few different columns. So now we can extract different values from the payload, and we can apply a function. We can say, well, take the latitude, longitude, and compare it to Olympia, and how far away is Robin from Olympia currently? And we can run that. Because we persist data in Kafka, it goes back to the beginning of the topic, so like the beginning of today, which is when I set this up, and here's all the data now. So it turns out at 13:21, I'm kind of pretty close to the location. If we page back up, I started off this morning in sunny Yorkshire, 290 kilometers away. So you can actually see it processes the data based on each individual message. Here's the battery status, was it plugged in or not? 1 means it was, 2 means it wasn't. So we've started to break down the data and pull out the useful fields. Here's a Kafka topic. What serialization format is it? It's JSON. Oh, cool. Here's my schema. I'm going to define the columns and data types. Well, now I've got a schema. I can run SQL. I can say, pull out this column, run this function, show me this data. It's kind of useful. It shows it on the screen. I could use the REST API and start kind of querying it out. But more useful is to say, well, that processing you've just applied to it, let's write that back to a Kafka topic. And that's what we're going to do here. There's a big, long set of SQL. I'm going to run it, and then I'm going to tell you what it does. So that's running. So the first important thing we've done here is we've said create stream as, oops, okay. When we say create stream as select, it's like a database, create table as select. Take this static lump of data, create table as select, here's a new static lump of data. Take this stream, create stream as select, create another stream that's populated from the first one with the results of our select. So the select could be just pick out these particular columns and apply a function. It could also be do a few more things to it. Let's say, let's look at the BS field and we'll say, well, let's apply what we know about it. If it's 1, the phone's unplugged. If it's 2, then it's charging. It's just a case statement. Okay? Hands up who knows SQL. So everyone knows SQL. Most people know there's the case statement, which is really cool for manipulating data. We can now start to build logic into this, and the results of that statement, okay, we've got more cases, we've got some other stuff, we've got some concatenation. So we're doing something here. We're saying, if the latitude or longitude is null, then we'll return null. Otherwise, let's concatenate it into a little geopoint, because we can use that subsequently. And all of this goes back to a Kafka topic. Show topics, we've got a new Kafka topic. Print phone data, limit 1. Just show me the first record. Okay, there's a Kafka topic with some data in that just happens to have been processed by KSQL, but it's just a Kafka topic. So whatever the endpoint for your data is, whether it's a service that you're writing, whether it's an analytics platform, the processing on your data, you can actually do using KSQL. It arrives in your Kafka topic, process the message, write it back to an enriched Kafka topic, and now it's just a Kafka topic. It's just a different one. It's called phone data. You'll notice, the eagle-eyed of you will have noticed, we've reserialized our data into Avro. If you want to know why you should use Avro and not JSON, come and speak to me afterwards. I will rant about it at length. TLDR, use Avro. Almost always use Avro. So we've got our data in Avro, KSQL's reserialized it for us, and we've got this new data. It's in a Kafka topic. So let's do something with it. We can query it, we can pick out different columns that we're interested in. Okay, select the values, there's our Moff, here's the current time, here's the values. Let's push our luck and see if the live demo is still going to work. Maybe it's not. There it is. Okay, so we send the data point, it goes through, it says, okay, 1327, 1328, so we've got the new value, it's unplugged, so we've taken the live stream of data, we've applied that manipulation to it, written it back to a Kafka topic. But because it's a Kafka topic, we can do more things with it. We can do this. Here's our MQT data coming in, we've processed it and enriched it with KSQL and written it back into Kafka, and now we're going to stream it down to Elasticsearch. How do we stream it to Elasticsearch? We use Kafka Connect. We could go and write a program. We could go and write some Java or some Python or some Spark, which is always fun. And we could say, read this topic and write it over there. And then the network goes bang. It's like, oh, how do I manage restarts? Kafka Connect. Create the sync. Here's our JSON configuration. We just send it to the REST API. We're going to use the Elasticsearch sync connector. Here's our Elasticsearch endpoint. Okay. We check that it's running. Because it's a live demo, it might not be. Turns out it is running. That's good. Set up Kibana. Kibana, if you're not familiar with it, is this nice front end on top of Elasticsearch. So we import the objects, and now we go and do this. We say, show me my live stream of data that's come in from a Kafka topic, that we've written some SQL to enrich and write back onto a Kafka topic, and we've written some JSON to take from that Kafka topic and stream down to Elasticsearch. So here's the data. We can see this morning there's a bunch of different movements. We can see 1327 was when I last sent it. If I push another couple down now, we can see 1328. So that's updating. Let me make it a bit bigger so those at the back can see it. We've got our live stream of data. We can also say, well, you've got some geodata in there. We've got stuff about the location. So let's build a map, because maps look nice and make for nice demos. So we can say, plot on the map where Robin has been. It says, you've been to Europe, let's zoom in a little bit. Well, it says, turns out you did indeed start in Yorkshire, and then the train went down there, your phone got a bit funny and went to sea, And it carried on down there, good old LNER, took us all the way down to King's Cross. And from King's Cross, we got in a taxi because the underground was knackered, and we made our way to Olympia. So you've tracked all of these different points, and I've built that out with some SQL to enrich it, and some JSON to say, Kafka Connect, take this topic, stream it to Elasticsearch. That's kind of a lot of data to be sharing, though. Like, I don't mind. This is a demo, and it's going to a secure server. It's like, oh, that's fine. But this kind of use of data is one of the things that Kafka excels at. Because that data is not deleted when I use it, we can use the same data in multiple different places. Maybe within the same team, maybe in different teams in the same organization. We run an app, we run a startup, we get the app on people's phones, we've got a live stream of people's location and information about their battery state, all this kind of stuff. It's like, oh my God, that's a lot of data. No way can we share that with anyone else. When the user signed up, they kind of like ticked this thing that said it was just before the app that they were doing. They want to share cat pictures, you can have my location, fine. Can we use that data for our analytics department? No way in hell, because we didn't sign up to that. But how about if we can take that live stream of data that we're using for this and building that out, and that's fine, and build a derived stream of data which says, well, if the user's opted in, we'll share their location. If not, we'll just share their battery status and so on. Because battery information, super valuable. Don't need the location stuff, just that. Or if they've opted in to share their location, they don't mind sharing their location, but except for within this, like, a privacy zone. So like, I don't want you to know where I actually live, but kind of like 2 kilometers outside of that, I don't care if you know I've been to London. Who cares? But I'm not going to tell you actually where I exactly live. So I can say you can have my location, but except within this area. And we can do this using KSQL. So the first thing we're going to do is we're going to go back to a database. Okay? Kafka and KSQL are starting to smell and look a little bit databasey. We've got a stream of events with a SQL interface to query it. But here's like a proper database, a relational database. We're going to use MySQL because this is where we've got information about our users. Most of the time, we tend to keep our reference information in a database. We've got our streams of events from wherever, reference information, database, because that's what we do. So in a database, we've got information about our users. Here's our users. Have they opted in to share their location? Yes, turns out I have. The other 2 haven't. We also need to handle the case where we've got data from someone and we don't know if they've opted in or not. And we're going to err on the side of caution. If they've not explicitly opted in, then we presume they haven't. And we've used Kafka Connect to stream the data through from the database, snapshot the database into a Kafka topic, and use CDC to take every single change from the database subsequently into that Kafka topic as well. So over in Kafka, in KSQL, show topics, we've got a topic here called users. This is our data from MySQL. It's a snapshot plus every single subsequent change. So it's basically a mirror of what's in the database. Something changes in the database, we have it in the Kafka topic. And we can model ourselves a table in KSQL. There's this thing called the stream table duality. I don't have time to talk about it now. I will at length afterwards, as well as Avro if you're interested. But stream table duality describes how you can go between a stream of events, which is what a Kafka topic is, and a table, which is state. Tell me the state for a given key. So just as in MySQL I said, select these values from users, over in KSQL, in Kafka, I can say, use that Kafka topic that you populated from the database and pretend it's a table. Show me the current state for each user. It says, well, the current state is this. And if I go back to the database and I say, let's update our users, and let's say Ivor has opted in. So in the database, we now have 2 opt-ins. Ivor has opted in. Let's go back over to Kafka. In KSQL, it says, haha, the state has changed. Ivor has now opted in. So it's emitted the new state. If I re-query the table and say, show me the current state based on this stream of events, it says, well, there is your current state. The current state is that 2 people have opted in. So we can take a database with whatever is happening, we can mirror it to a Kafka topic, which is a stream of events, and we can treat that stream of events as a table. And now that it's a table, we can do a join. So KSQL lets you do case, it lets you do transformations, it lets you do filtering, it lets you do joins. I can do a join between a stream and a table, which is actually a stream, it's a topic underneath, but we're going to treat it as a table. We don't want a Cartesian, we want to say, what's the current state for this user? we can do this. Select the values, do a left join to users. Okay, I push a new data point. It says, here's Robin. Has he opted to share his location? Yes, he has. Okay, and there's my location. So the value comes in. In fact, let's set a data generator running. So run data gen. So now we've got different values coming in. And if I pause that, we can see my dummy users are busy. Here's Hugh. Turns out he's not opted in. Here's Ivor. Ivor has Rick. We don't know about. So we assume that they've not opted in. So what we can do from that, we can create ourselves a new stream down here. Whoops. The reason I have the cheat sheet is A, so that you can take it away and run it, and B, so that I don't make typos, because typing this from memory is not going to work. But all we've done, the actual payload that we've got here, is said, here's a great big case statement. If they've opted in, then let's look at the geodistance between their privacy location, latitude, longitude. If it's greater than their zone, then we'll share location field. Otherwise, we say it's the private area. If they've not opted in, we say they've opted out. And otherwise, we'll say it's no record. It's just a case statement, expressed in SQL, but it's now a stream processing application. We run that. It says, well, it's not going to work because it's a live demo. And we put that in. It says it might work. But what we can do now is we can look at that result and say, let's have a look at the data. It says, here's Robin. And we can see that we're within a kilometre of the privacy zone. If I set the data generator running and look at all the other users, we can see some of them, it's going to share the location. Okay, so here it shares my location because I opted in. Either we don't know, Hugh opted out. So you've got a live Kafka topic, taking a stream of data from a Kafka topic, enriching it, adding in privacy filters, and we've now got a new Kafka topic here. Show topics, phone location data opt in. We can set the security, we can let other teams access that. Saying, here's the data people have opted into sharing, we can prove it, we've got the application here. In fact, here's the SQL, you can go and look for yourself, it's SQL and you can read it. So that, at a bit of pace, is what KSQL is, and that's how you can actually use it. The code, as I say, is on GitHub. If you're on Twitter, I'll be tweeting it. You can find it if you Google for like I'm off demos, you'll find it as well. That's the kind of stuff you can build out. I didn't get a chance to show you the fancy dashboard. There's the route down. You can analyze the data. You can look at battery status. But you can use the most appropriate tool. That's one of the key things from this. Kafka persists data. It's not transient. Kafka does stream processing. Kafka doesn't do everything. Kafka's not great at ad hoc analysis. Something like Elasticsearch or Athena or something else is designed for it. So you do your processing in the most appropriate place, which is generally going to be when the data arrives, and then you stream the data elsewhere as and when you need. Sometimes you don't need. You could build the aggregates in KSQL themselves and serve them directly, but sometimes you want more kind of analytics-based stuff. You can stream the data down like that, but it's all based on streams. It's all based on the events. So this is built using Confluent Cloud. So the Kafka cluster itself is running on Confluent Cloud. Confluent Cloud is a fully managed Kafka service. So if you're interested in trying out Kafka, go and sign up. There's kind of like a $50 credit that you can take advantage of. It also has managed schema registry for your Avro schemas, which are super important. You should be using Avro. It has managed KSQL, managed Kafka Connect, and so on. So go and give that a try. Come along to our booth if you want to know more about that. Briefly, to interact with KSQL, you can use Confluent Control Center. You can use the Confluent Cloud user interface as well to do web-based work with it. You can use the command line interface like I showed you. You can use a REST API if you want to. When it comes to running KSQL and developing with it, you prototype your stuff exactly like I showed you there. Let's run this select. Let's try out a predicate. Let's kind of work out what our data needs to look like. And then we take that SQL statement. We stick create stream as select on the top or create table as select. Remember stream table duality? That gives us a code file, a SQL file. That is our code that goes into source control, that whatever, that when we run through our test harness, we drop that onto a KSQL server. There's no kind of like Java type stuff, and I can swear to that because I don't write Java, I promise. It's just SQL. Take the SQL, deploy it onto the server. You can run KSQL however you want. You can let us run it for you in Confluent Cloud. You can run it on Docker, bare metal, Kubernetes, etc., etc., etc. A very important point about KSQL, two very important points. One is it does not run on your Kafka brokers. Nothing runs on your Kafka brokers except your Kafka brokers, possibly Zookeeper, some would disagree. But your KSQL servers, they run separately. You can cluster them. They're built on Kafka Streams, they scale out, they're fault tolerant, and so on and so on. But you don't generally just have one great big KSQL cluster. This is not like your data warehouse, where here's my data warehouse, I do my analytics, I do my ETL, it's the big data warehouse, we have a nice big one, and everything happens there. KSQL applications are applications. In the same way you would provision and deploy and architect applications, so are KSQL applications. So you would have a couple of KSQLs over here for doing like fraud detection, a couple over there for stream processing on this, maybe one over here for kind of like a bit of sandbox work, but you deploy them separately. If you want to know more about Kafka, about KSQL, I'll be heading straight to the Confluent booth, which is somewhere over there. Come and speak to me about it. There's also a really good set of books that you can download for free off our website. So scan the QR code, go to the thing, and you can download those for free. With that, I am out of time. I will take lots of questions if you have them over at the Confluent booth. Thank you very much.